Hey everyone, welcome to part 2 of factoring trinomials with a leading coefficient other than 1. Let's jump right into more practice. So we have 4x squared plus 4x minus 15 as the trinomial we're trying to factor. Now, leading coefficient nor the constant term is prime, so we'll use our grouping technique. So 4 times negative 15 gives us negative 60. So we need to come up with a factor pair of negative 60 that adds to positive 4. So let's see, I think that would be 10 and negative 6. So that's negative 60 adds to positive 4. Perfect. Now if we didn't get it on the first shot, we'd list out a couple more factor pairs until we found the one that works. So we can rewrite this as 4x squared plus 10x minus 6x minus 15. We'll group the first two terms together, the second two terms together. Now because I included the subtraction sign, make sure I add that addition sign between the two parentheses. Greatest common factor of the first two terms is 2x, and then we'd be left with 2x plus 5. Now because we want 2x plus 5, we're going to factor a negative GCF out. So we'll factor out negative 3, and that will leave us 2x plus 5. So the two terms have a greatest common factor of 2x plus 5. So we'll factor that out. And then we'd be left with 2x plus negative 3, which we'll just write as 2x minus 3. And again, another reminder, if we have the time, multiply our factors out, and we should confirm that we get 4x squared plus 4x minus 15. Next up, 6x squared minus 17x plus 10. Okay, leading coefficient, constant term are not prime, so we'll multiply 6 and 10, and we'll also get 60 again. But now we need a factor pair of 60 that adds to negative 17. Okay, so let's see. Does negative 5 and negative 12 work? Well, negative 5 times negative 12 is 60, and that would add up to be negative 17. Okay? So now we're going to rewrite this as 6x squared minus 5x minus 12x plus 10. We'll group our first two terms together and our second two terms together. Again, making sure there is that addition sign between our parentheses. The greatest common factor of the first two terms is just x, and we'd be left with 6x minus 5, plus we're going to need to factor out a negative 2, so that we have 6x minus 5. 6x minus 5 is the greatest common factor. And then we have x plus negative 2, which is going to be x minus 2. And there we have the factors of 6x squared minus 17x plus 10. So this is a nice review on our grouping technique. 9x squared plus 35x minus 4. So leading coefficient, constant term, both not prime. So we'll multiply 9 and negative 4. We get negative 36. So we need a factor pair of negative 36 that adds to 35. Well, that's just 36 times negative 1. So we can rewrite our trinomial as 9x squared plus 36x minus x minus 4. We can group our first two terms together, our second two terms together. Get that plus sign in between. Greatest common factor of the first two terms is 9x. Leave us x plus 4. To get x plus 4, we're going to factor out a negative 1. And then we have x plus 4. Greatest common factor between those terms is x plus 4, so we'll factor that out. And we'd be left with 9x plus negative 1, which is 9x minus 1. Next up, 9x squared plus 18x plus 5. So the constant term is prime. So let's go with the guess and check method. So building backwards, we know 5 and 1 are the only two factors of 5. Now for 9x squared, we can either have 9x and x or 3x and 3x. Well, let's try 3x and 3x first because we don't have to worry about switching them. Right? They'd both be 3x. And I should have also noticed I'm multiplying to a positive 5 and adding to a positive 18. So both of these should be positive. So let's check. So we'd have 3x times 1, which is 3x. 5 times 3x is 15x. Add those two together, we get 18x. Perfect. There are the factors. Now, what if we're trying really hard, we're trying the grouping method, we've listed out all our factor pairs, and we just can't come up with one. And we think that the quadratic, the trinomial, might not be factorable. So remember, we can find the discriminant of the trinomial. And just as a reminder, the discriminant is b squared minus 4ac. If you don't remember this, I would encourage you to go back and watch part 2 of the first trinomial factoring video to get a little bit more explanation here. So we're going to find the discriminant to decide if the trinomial is factorable. Right? We're looking for the discriminant to be a perfect square. So in this first example, 2x squared minus x minus 3. Okay, so let's list out our values. So a is 2, b is negative 1, c is negative 3. So our discriminant, which is capital D, is, let's see, b squared, so negative 1 squared, minus 4 times a times c. So negative 1 squared is positive 1, minus 4 times 2 is 8, times negative 3 is negative 24. So that's going to be 25. So that is a perfect square. Perfect square. PS, we'll abbreviate it. So that means I can factor 2x squared minus x minus 3. So let's do that. I should notice that both the leading coefficient and the constant term is prime. So we'll start our factors as 2x and x to get 2x squared. And then we need to figure out where to place the factors of 3 so that we get negative 3 when we multiply and negative 1 when we add. So let's see. If we do 3 and 1, we would have 3x and 2x. And we want to get negative x. So the 3x would need to be negative, and we would get that. So negative 3 plus 1. Negative 3 times positive 1 is negative 3. So we're good. There are the factors of 2x squared minus x minus 3. Next example, 2x squared plus x plus 5. So a is 2, b is 1, c is 5. So what's our discriminant? So we have 1 squared minus 4 times 2 times 5. So we have 1 minus 4 times 2 is 8, times 5 is 40. So we have negative 39. Well, a negative number cannot be a perfect square. So this is not a perfect square. So that means that this trinomial is not factorable. Okay. Next, 3x squared minus 2x minus 4. So a is 3, b is negative 2, c is negative 4. So what is our discriminant? So we have negative 2 squared minus 4 times 3 times negative 4. So we have 4 minus, so 4 times 3 is 12, times negative 4 is negative 48. So that would be positive 52. So again, not a perfect square. So that means 3x squared minus 2x minus 4 is not factorable. Okay, so again, for those problems that you're just banging your head against the wall, you just can't seem to come up with the factors, check the discriminant. See what you get, because that might tell you whether it's worthwhile to keep trying or not. Now, what happens when they throw a y into the trinomial with a leading coefficient that's not 1? Well, what if we treated the problem without the y? So 2x squared minus 9x minus 5. Can we factor that? Well, leading coefficient and the constant term are prime. So we'd have 2x and x. And let's see, the only factors of 5 are 5 and 1, so that's actually nice. I need negative 9. So I think I want to multiply the 5 and the 2 because I'd get 10. So let's see. If I put the 5 there and the 1 there, I would have 10x and x. And I want negative 9x. So I'd want this to be negative and this to be positive. Okay, so how do I make the adjustment when now I have y and a y squared in our trinomial? So all that's going to change, instead of 2x plus 1, it's going to be 2x plus y. And then instead of x minus 5, x minus 5y. And if we distribute, we'd get negative 10xy plus xy, which is minus 9xy. And then y times negative 5y is negative 5y squared. Last example. If the factors of 10x squared plus 11x minus 6 are 5x minus 2 and 2x plus k, what is the value of k? So essentially, they're asking us to factor 10x squared plus 11x minus 6 and compare our factors with what they told us and see what we get. So 10x squared plus 11x minus 6. Now normally, because 10 and negative 6 are not prime, we would use grouping. But they already gave us one of the factors. So let's see if we can just figure out what the other factor is. They already told us that's 2x. So let's see. We need to multiply negative 2 by something to get negative 6. Well, that would be plus 3. Now let's see if that makes sense. Well, we'd get 10x squared. That's good. 15x minus 4x, which is 11x, and then negative 6. So that's perfect. And we're comparing it to the factor 2x plus k, so that means that k equals 3. We could also do our grouping method just for practice here and get our factors, see what they are, compare them, and see that k equals 3. Okay, so there is how to factor a trinomial when the leading coefficient is not 1. In this video, we spent more time practicing. We looked at our discriminant to determine whether or not a trinomial with a leading coefficient that's not 1 is prime, meaning can it be factored or is it not factorable? And then we wrapped up with a few other questions. So now it's up to you to practice as many factoring problems as you can so that you become an expert at factoring trinomials. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.